Okay, in this video we're going to use the AlgebraTile app to help solve simple equations. Keeping in mind that when I want to solve an equation, I'm looking for a particular value that makes the one side of the equation the same as the other side of the equation. Okay, so let's look here. So how I've got this set up is I'm going to look at these examples on this page, which you can download and print off if you like. And over here I have my AlgebraTile app running, and I'm going to manipulate or use the app to help solve these equations. Okay, so say I have to solve x plus 3 equals 7. Now, sometimes it's easy to quickly say, well, I know what x must be, so that the left side of this equation comes out to be 7, which is the right side of the equation. So that might seem easy here, but what we're going to be working towards are some skills that will help solve more complex equations. For example, when we get down to down here, okay, so it might not be as easy to see. So I'm gonna do a couple quick video examples. So here's the first one, just to start. So notice how I've set up my AlgebraTile app. Make sure you choose equations down here, and that will set up the two sides. Okay, so this is like the left side of the equation and the right side of the equation. And notice with our tiles, I dragged an X out here, and then I got 3 1s, which are like our algebra tiles from before. That's the left side of the equation. The right side of the equation, I put 7 singles over there. So our job here is to solve for X. And our rule, we've got a rule, whatever I do to one side, I have to do to the other. And the idea here is, can I manipulate this so that I have X on one side and the numbers on the other, which means I've got another equation that says x equals a certain number. That's what we're trying to do here. So watch what I do here. I want to, if x is here already, I want to isolate that x so there's nothing around it. And notice I've got these ones sitting around it, and what I want to do is I want to make those ones 0. I want to get rid of them. Okay, so for example, if I bring a -1 over and I plop it down on top of that one, okay, I've just added -1 to this side, and notice 1 and -1 together, 1 plus -1 is 0, so that would make a 0 right there. But keeping in my rule, if I drop this down right there, I have to do it to the other side too. And this is, if you've been playing Dragon Box, then you've already experienced some of this. Okay, so I plopped one -1 down, one -1 down over on the other side. Now I want to make this one 0 too, so I'm going to bring it down there, but I got to do it to the other side, so I'll just drop it on the other side. And I want to make this one 0 too, so I'm going to drop it down there, and I'll bring one more over there. Okay, so now notice, if I drop these on top, they disappear. They do make the 0. And now my x is isolated. It's gone. And that was my goal, get that x isolated. So remove those singles so that we can get x isolated. Now, I'm going to clean up this side over here, because notice the expression. It says 1x on the left, and I've got this 7 plus -3 over here. So I can simplify by matching up our 0 principle, which is making zeros wherever we can. And now I've got a situation where I have 1x is the same as 4 1s. And you probably guessed that was the solution to x at the beginning. So that's how we can use our algebra tiles to solve an equation. Now I'm going to get a little bit harder. Okay, so I'm going to show you what you can do when we have a situation like this. Okay, so you're going to go back and do some of those examples using your algebra tiles and your AlgebraTile app, and you'll record your solutions. Now I'm going to solve this, and I'll show you what this one looks like. So let's clear this off here. And let's set up, the left side says 6, so I got 1, 2, and I don't know, something you can do to help yourself along here is I could say, well, I've got 2, I need 3, 4, 5, and I need one more, 6. That's fast. So I got 6 there on the left, and I need 3 x's on the right. So now notice I've got 3 x's to deal with in this situation. But also the x's, there are no singles around to isolate on those x's. If I did, I would do the same thing we did on the last slide. We'd try to make it zeros. So since there are 3 x's here, there's nothing to really, I can't eliminate an x. I want to keep the x's all together. But what I can do is, I've got 3 x's is the same as 6. And you might have already guessed what the x must be so that we get 6 on the left. Here's how we're going to show this with algebra tiles. That once I have all x's on one side and all singles on the other, I start to line up each of the x's with the remaining singles. So notice I've given each x a single. So each x so far has one single. And if I keep doing that, you'll notice that each x ended up getting 2. And since we want to evenly distribute all those singles to the x's, which gives us a statement that says 1x is the same as 2, which is our solution. X must be equal to 2. And you would have maybe guessed that already. So let's do maybe one more harder example where we combine some of these ideas. Let's look at this one. So I'll clear all this off. Okay. And I'm going to set up 13 on the right. Or sorry, on the left. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so there's 13, and I need 3 x's over here. 1, 2, 3. And I need 4 singles over there. 1, 2, 3, 4. Okay, so here's our equation and algebra tiles set up. I'm going to solve for x. Notice this time I've got some singles over there that I do not want. So I'm going to bring in 4 of these negatives. 1, 2, 3, 4. And that will eliminate those 4 when I drop them on top. But remember our rule, whatever I do to one side, I've got to do to the other. So I need to bring 4 over here. 1, 2, 3, 4. And now let's clean up a little bit. Okay, so we're going to get these singles dropped out. And we'll do the same over here. Match each one of these up. And then notice we have our x's isolated. And now we've got a statement that says 3x on the right is the same as 9 on the left, and we do what we did in the last example. We evenly want to split up the remaining x's into the x into the numbers. And really what we're doing is we're taking the 9, which was 9, there it goes, and dividing it by the 3, and that gives us with 1x equals 3. So our solution here is an x equals 3, and that's how we want to write it at the end.